Welcome to Brain Vision.
0.60. So we have a mechanical oscillator jiggling this rope. Here it moves little enough that we can consider this to be a node. This point is also an antinode. It's tensioned by this mass m. The distance between those 2 points is 1.2 meters. The frequency is 120 hertz. And we're told that standing waves are produced for values of this mass of 286.1 grams and 447.0 grams, but for no mass, not for any masses in between those. And we want to find the mass density of this rope or string or whatever. So this is a little bit involved, but it's a 3-dot problem, so you'd expect that. But we can get through it. So the frequency of the nth mode is NV over 2L. Now we can write this as N over 2L times the square root of the tension, which is equal to the weight of the mass, divided by the mass density, which is what we want. So then this implies that the mass that produces the nth harmonic is 4L squared, F squared, times the density divided by N squared G. So we see that the block mass is proportional to 1 over the mode number squared. So what we can do is then take the ratio of our two masses, so we say that this is the nth mode and this is the n+1 mode, because there's no standing wave for any masses in between these two, so they have to represent adjacent modes of the string. So we get an n+1 squared and an n squared. So now this is equal to 1 plus 2n+1 over n squared. Or, if we evaluate this and subtract 1 from it, 0.5624 has to equal an odd integer divided by a squared integer. So what we can do is multiply this number by 1, 4, 9, 16, etc. until we get one that's either exactly, and we're not going to get an exact odd integer, but we'll get something that's close enough within the sort of precision that we have established by the number of significant digits in this problem until we get, so we want an odd integer then. So if we multiply this by 16, You just start out at 1 and keep going until you get 1. 5, 6, 2, 4. This is very close to 9. So n equals 4, which is to say n squared equals 16, and 2n plus 1 equals 9. So this implies that for our mass we said corresponded to n, which is our 447 grams, or expressing that in kilograms so we get the right number, n equals 4. So we can plug that into our equation we got earlier that we've rearranged to find mu. So it's n squared gm over 4l squared f squared. And so we get that the linear density of our string is 0.845 grams per meter.